Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Hi, welcome to Schweitzer Drive. I'm Dave Whitehead, CEO of Schweitzer Engineering Laboratories, and we've got a great program for you today. We've all heard the terms like contractor-grade or medical grade. These labels are used in various industries to convey information about the quality of something. In today's episode, we're going to delve into what it means for something to be utility grade. Given that utilities are tasked with providing a continuous flow of electricity to our homes, hospitals, schools, and critical infrastructure, I'd say it's a pretty important topic. My guest today is Adrian Genz, Quality Director at SEL. Adrian began his career as a SEL summer intern in R&D while he was earning his Bachelor of Science degree in electrical engineering from Utah State University. In 2007, he became a full-time employee. Over the years, he served in a number of design and management roles. As quality director, Adrian oversees the teams that specialize in data analysis, reliability engineering, and customer communications. And that's an interesting part. Maybe we'll pull the thread on that just a little bit, Adrian. Whether it's getting to the root cause of a problem or improving a process, his team supports the entire company for teaching, facilitating, training, analyzing, and testing for all things quality. Hi, Adrian. Thank you for taking the time to talk with me today. Let's jump right into this.
Sounds good, Dave. Thanks for having me.
This concept of utility grade, right, is near and dear to my heart. So let's start out with this. What makes something utility grade?
So I think it's something that's got to be dependable. The products that are protecting the power system and waiting to make a decision if they need to trip a breaker or something else like that, they have to be operating 24/7, nonstop. And so it's really important that they're always functional and working. I think another thing that makes something utility grade is something that lasts a long time, that doesn't need to be replaced every couple years. And so, we look to a 20-year design life on our products. And then I think one of the last things that when I think of when I'm thinking utility grade is that it survives really tough or harsh environments.
I think we're going to touch on all of those different points because I think you have to combine all of that stuff together really to come up with something that is utility grade. So let's get a little bit more into the details here. The devices SEL and other companies design and manufacture for use throughout electric power systems around the world are subjected to some very harsh environments. What are these harsh environments and what type of locations and conditions require utility grade equipment?
Sure. So one of the most obvious ones that comes to mind is temperature, right? So things that really hot and arid conditions or really cold conditions. So whether you're in Death Valley in California or in some really cold environment, say in Canada.
And these aren't hypothetical, right? You're really saying we have equipment installed in, say, Death Valley, hanging on a pole out somewhere in the middle of the desert, or hanging on a pole somewhere in the middle of an Arctic condition.
Absolutely. Yeah.
Hey, and how hot or cold are those temperatures? Certainly the ones we design for, maybe even exceed.
Well, so we design our products to survive minus 40 degrees Celsius to 85 degrees Celsius.
And if we put that into U.S. temperatures, what might those be?
So minus 40 Celsius actually happens to be minus 40 degrees Fahrenheit.
I like that one.
That one's easy to remember. And then I think 85 degrees Celsius is something like 185 degrees Fahrenheit. So it's super hot. In fact, there isn't a place on Earth, I think, that's that hot, right? I think one of the hottest places, of course, is Death Valley, as I mentioned. And I think their record temperature was maybe around 54 degrees Celsius or 135 degrees Fahrenheit. Maybe 100 years ago it was recorded. So,
and even getting to minus 40 would be pretty tough for a product. I was watching the Green Bay playoff game this weekend, and it was -2. I did go to Russia one time, and it was -20 when I got off the airplane. So that's getting pretty cold. I don't know if I've actually been in -40 condition.
Yeah, I think I've only been as cold as -10 when driving through Nebraska one winter. I remember seeing that. I think there's some places on the earth, like the North Pole, that are -60 or something like that. But I think most habitable places are not that cold. So.
Yeah. And we actually did some work for airplane manufacturer. We were testing to -60 one time on some of our products, well, a design anyway. So that gets pretty intriguing. What else besides temperature would we consider a harsh environment?
I think whenever we start talking about humidity or corrosive environments, things that are installed around the coastline where there's salt in the air, I think that can add an extra element of harshness, especially to products that are installed, not in a controlled substation house environment, but they might be out on a pole, right? And so that can wreak havoc on the materials we use to build products.
I used to not think of humidity as all of that big a problem. And this goes way back when I first started working at SEL, because as a young hardware engineer, I put a product in a temperature and humidity chamber and brought up the humidity, and all of a sudden the product stopped working. And as hardware designers, maybe you don't consider these high impedance nodes, and if you get just a little bit of contamination, and that impedance changes the way that the circuit works, right, as a function of humidity. It's something, very early on in my career, grabbed my attention, and now I'm really, I think a lot about it a lot. Maybe in other hardware design projects, if I was working in other industries, I wouldn't care as much, but certainly in ours, it's a big deal.
Yeah, I don't remember about learning about that in school.
I never took a class on humidity and its effect on high impedance nodes.
Or really any of these harsh environments for me. There was not a design for harsh environments class, right? It was all, I learned a lot when I came here to SEL.
Adrian, we've talked a little bit about temperature and humidity, but there's another side to quality of products or these harsh environments that they have to work in, and those involve electromagnetic interference. You want to describe some of those? Yeah.
So when I think of electromagnetic interference or radio interference, I think that's something that can take place in a lot of different environments and can affect a lot of different products. Especially when I think about radio interference, we have, whether it's a radio or a phone, or these are all kinds of devices that are causing interference. And we have to make sure that products that are being established, are installed in these substation environments or utility grade are not going to be interrupted by those types of interference. So that's something to be aware of. I when I think of that type of interference, I often think of the situation when I had really small children and we had a baby monitor in our house, and it was operating on I think it was 900 megahertz, and I remember picking up the neighbor talking on their phone across the street. I think it was them, at least. It's kind of hard to hear everything they were saying, but and so that's one type of interference. Now, while these utility grade products and substations aren't necessarily playing audio back or anything like that, it's the same kind of concept. So that's something, as engineers, you have to make sure that products are designed to be immune to that kind of interference.
Yeah, we've done a lot of work with simulating, RF offenders. We'll blast a bunch of radiation, RF energy at our products to make sure they continue to operate in a safe manner. It's amazing the kind of energies that we have to perform to ensure the reliability of our product. Maybe to put that into context, that while we're recording this podcast, the FAA and the FCC are kind of going to war over 5G cell bands and the interference that might come into play with the altimeter radar on certain airplanes, right? And that's an allocation of spectrum and how much RF energy bleeds over into one part of the spectrum versus the other. So interesting problems we see across industries, not just ours. Though ours I think are a little bit harder to deal with, if you will, because we have, these unintended or maybe intended radiators that we have to make sure don't impact the quality of our products.
Absolutely. And we have some pretty large RF chambers at SEL where we'll put the product on a table. And
how big are those? We call it a 10-meter chamber.
Yeah. It's
I like to say it's 30 feet by 30 feet by about 75 feet. So if you want to put it into context, I drive an F-150. I could drive that car or that truck into the RFI chamber to see how much emissions come out of my F-150 if I wanted to.
Yeah, so you mentioned emissions, right? That's the other thing. We need to make sure that we're not an interferer to other products as well. And so that's another test we do. But in one of the smaller chambers, I think it's a 3-meter chamber, we point an antenna at it and subject it to a certain field strength, our products to a certain field strength, and see if they, behave. Are they still functional? I remember during a design, before we had released a product, we were doing some testing, and we would sweep through different frequencies, while subjecting the product to RF, and we'd see a measurement all of a sudden change, and that was an indication that this interference was causing an issue. So we had to design around that.
And if you're not close to this, some of these tests, usually way a type test standard gets implemented is because somebody sees something happen in the field. So we talk about RF energy and its influence on the performance of a particular device. I remember when I started back here at SEL in, say, 1994, I was sitting talking to Ed Schweitzer about some of these type tests that we do. And he goes, yeah, think about this scenario. A lineman comes into a substation. He's, trying to talk to his boss on his walkie-talkie. He keys up the walkie-talkie, and all of a sudden the light's on a digital fault recorder or some other microprocessor-based device, lights off and trips out the entire substation. So that's what we're trying to guard against. Certainly, that a walkie-talkie from our devices has never caused, RF from a walkie-talkie has never caused one of our devices to light off. But that's what we're trying to guard against.
Absolutely.
Few products these days, especially electronic and other digital devices, are built to last or perform over 20 years. What are the challenges of designing and building digital equipment to withstand the utility environments? And if electronic and digital devices can be built to last, why aren't they? So, why does my TV last, 20 years?
I think when we're designing a product to be utility grade, we're looking for specifically all the specific components that are going to be on those circuit boards or within the products, that they can survive those temperatures, that they can last that long. And so when we look for those components, there is an additional cost that comes into play in that long-term reliability. And when you're looking at your TVs, or the one I always think about is the cable modem, right? I don't know how often you've had to replace your cable modem or your wireless router, but it seems like for me it's every 2 to 3 years. And I think that those components are probably not built to last the same duration.
Well, what I've noticed, I was thinking about a TV. If you had a CRT tube TV, I bet it still works if you could even pick up a signal with it anymore. But maybe for a TV, I think the reason I replace them is because they get bigger and bigger and bigger, right? And cheaper and cheaper and cheaper. So that's probably my motivation. I hadn't thought about the cable modem directly, but now that you bring it up, that thing breaks all the time. And here's why I bet it is. And you're the quality expert, so check my assumptions or my facts on that. Is those things run so dang hot, right? I could roast a marshmallow, I think, on it. And as I recall, is for every degree or every 10 degrees, you like half the life of an IC, the hotter you run it, right? So the cooler you can run an IC, the longer it's going to run. And I know we've got some design practices, where we want to only have so many watts per cubic inch of device, right? So the cooler we can run our devices, whether it's through heat sinking or just running things in a low power mode, the longer the device is going to last.
Yeah, because I think one thing that a lot of those devices have in common is they don't use fans, right? So if you're not over there spraying it off and dusting it off, that dust settles on the integrated circuits, and yeah, that's just going to it's like a blanket, right? It's going to keep that heat in, and they're going to not last as long.
Yeah, we're a pretty proper company, but fans here is the 4-letter F word at SEL. No fans in any of our products.
Yeah, so it's important then. Talking about this harsh environment, dust is another thing, right? So it's important that we look at making sure everything's enclosed properly, and we actually have a test for that where we some of our products will be put into to make sure that dust, if I think this is maybe done out of house, but where it's subjected to a bunch of dust, and we see how much gets in and we measure that, and that helps us know whether we have a dust ingress problem.
Back in the day, we used to have that dust generator machine, right? I can remember it was pretty big, right? It was probably like 5 feet by 5 feet by 10 feet tall or something like that. And you pull out the product to see what kind of chalky dust got inside the product.
Yeah. Yeah. And we look for that because, again, we want to minimize what's settling on all the components and causing the heat to stay in.
I remember talking with Ed Schweitzer about fans one time, and he goes, let's think about this, Dave. What is that fan? All it turns your device into is a vacuum cleaner that's going to suck out all the dust in a substation to deposit it on the circuit boards of your product. So that's one of the reasons we've avoided, as you pointed out. It's just it will. While fans maybe have a short-term cooling effect, the long-term effect is it's probably going to impact reliability. And fans break. It's probably anything that moves or spins, right, is going to wear out a lot faster than something that's just a solid-state device. So putting a fan in a substation that you expect to run for 20 years is probably a bad idea, number 102.
Yeah. Yeah, and if you look at any of those devices that have fans, like a computer, you look inside, there's still plenty of dust in there, right?
So Adrian, we've talked about the 20-year life design cycle. Does this stuff really, really last for 20 years?
Yeah, yes, it does. We had an interesting experience a couple years ago where a customer was decommissioning a bunch of their products from the substation because they were putting in new stuff with newer features and just an update to the technology. And they said, "Hey, would you like to receive these products back? Otherwise, we're just going to scrap them and get rid of them." And we said, "Sure, yeah, let's take a look at this stuff." So we had an opportunity, and these products were 20 to 25 years old, to take them apart, look at the different, just do visual inspections, but also go to the most critical components and verify that they hadn't changed at all, right? When we're talking about the most critical electronic components, we're talking about resistors with a really high tolerance or a crystal oscillator that keeps the time, right? All of those things, we checked the parameters and they were spot on. So it was really cool to see that and to look at those devices.
Hey, let's pull on that thread though too. So you guys have done a great job being able to derate components to extend their life, work in harsher environments. But at some point, the electrolytic capacitors are going to dry out. So I've been talking with a handful of folks at utilities, right? And I think I'm of the opinion, wow, you guys have done an excellent job of designing it for 20 years. We'll probably see useful life of maybe 25, maybe even 30 years. We have some products that are that old still in service. But I really do think it's incumbent on us to work with customers or others to have a replacement program so that, we're ahead of the curve when things are going to wear out and need to be replaced. I think the quality data that you've shown me and that I've looked at doesn't show any uptick in unreliability or unquality of the products that are still in service these days. But I'm really interested in coming up with a strategy and a smart replacement program just to stay ahead of the curve, take advantages of new features and performance and cybersecurity and a whole bunch of other things that'll probably reduce O&M equipment cost or outages if we can, proactively replace these products that have been in service for 20 years. I don't know what your thoughts are about that.
I agree with you that certainly our products are doing well, exceeding that intended design life of 20 years. But some of these components, like you mentioned, Dave, aluminum electrolytic capacitors and power supplies. I mean, those capacitors are in pretty much every power supply, not just utility grade products. And eventually that electrolyte will dry out over time, and whether it's 25 or 30 years. And so I think that at some point the decision has to be made. Okay, things are working well, but let's replace this. And one of the big factors that can drive that is, okay, what's the benefit? What are the new enhancements? What's the new technology, right? And so I think teaching that will, what's the right time and helping make those recommendations will help our customers.
It's just to rattle off a few is just from the innovations, right? The fault locating is much better. The processing, the ability the sensitivity for detecting faults, all of the new features we have in say our latest generation of relay compared to say a 20-year-old product are just orders of magnitude better. The integration from communications and things like that provides visibility into the power system. Probably argue that your O&M costs will go down because, we have a lot more diagnostics, ability to really figure out what's going on in the power system, so you don't have to send folks out into a substation to see what's going on. All of this, I think, rolled together to allow a proactive replacement of older products versus a reactive perspective. I think there's a lot of benefits, but that's probably a talk for another day too, on when is the right time to come up with a relay replacement program. I've seen some products out in the field that look vintage. It's always cool to encounter one of our early products that is still in operation after 20 years. What's the oldest SEL product you've seen still in operation?
Yeah, so I've been at a few substations, and in one of the areas I worked on the most was recloser controls. So I've seen some older recloser controls, but I think our first recloser control was released probably around 1999. So that's probably the oldest one I've seen out there. But we did have an SEL 121 from 1992 that was returned for a failure in the power supply after 29 years. So that's at least the oldest one I know on record.
Wow.
But we know that there's others still out there, right? But that's just the oldest one I've seen.
That's great. That is a great story. Going back to my early hardware engineering days, always the funnest part of a project is getting that first prototype up and running. And then I have to remind myself is getting something up and running one time is probably 5% of the entire design cycle. Trying to design something that you can build 10,000, 100,000 of every single day up in manufacturing is certainly a challenge for all of us. What are your thoughts on being able to build 10,000 of something or 100,000 of something? Are there different things you need to consider when you're doing the design? What are your thoughts there?
Well, I think, I'll talk a little bit about the design, but one thing aside that I think really sticks out in my mind is the culture and the fundamentals and that you follow as an organization, how important that is. Because if you build on a really strong foundation and you're building work instructions or design processes based on that, that's gonna help ensure more robust product and consistent product going forward. But I like the analogy of a peanut butter and jelly sandwich, right? You can make it a lot of different ways. But if you want it made a certain way with just the right number of ingredients, you need to write out the work instruction or write out the steps and how it's done. There's always some room for creativity and innovation as long as you're not jeopardizing quality. But if you can make sure that, if you want to build it consistently to like you said, the 10,000th time, processes are really important and key.
And that's the one thing I've really appreciated and learned from your folks in the quality department is these KPIs or these key measurements we can look where we have an expected variation, from product to product, and then if we start drifting towards one of those boundaries on what's acceptable or not acceptable. I think you guys have taught us a lot, right? Certainly, again, going back to when I was in college, they never taught me about these kind of things, but it's from a reproducibility, a quality standpoint, the rigor and the science that you guys have put in place here, certainly at SEL, is, I think, a big contributing factor to building these high reliability, high quality products that are going to be into service for 10, 20, 30 years. What are your thoughts? Well, certainly way more than 10. Let me clarify that. 20 to 30 years, certainly. Yeah. What are your thoughts about how you go about implementing processes like that? Or what if somebody's trying to set up an assembly line or something like that, what should they be thinking about from a reproducibility?
Yeah, so I think after you establish those steps and those work instructions, measuring the output, right? And measuring the types of defects you have, right? So we talk about using a Pareto chart to make it very visual and making sure that those directly involved with building it can see that information. And then another, and sometimes surprising way to look at this is lead time, right? Measuring the lead time of how long it takes to build something, because if you see that drifting or changing dramatically, or that could be an indication that there's a lot of rework or a lot of problems along the way. So I think just some strong instructions on how to build something, and then having some measurements in place that can be visibly seen at all times and acted upon, and that kind of having that spirit of continuous improvement, right? How could we do better? How could we make this better? This maybe we have a defect once a month on this thing, but how could we eliminate that altogether? How could we make improvements? And so having that eye towards continuous improvement. I
think you hit on something too that maybe I take for granted, but recording information and sticking in a database, or let's call it a quality database, really doesn't do anybody any good, right? There's probably a handful of statisticians who maybe do some analysis, that maybe do something. The fact that you guys record stuff, or our folks throughout our company will record stuff and they make it really, really visible, I think is really a powerful quality tool, because if folks that are working on the process, doing something, can see that, hey, there's a blip or a glitch in our quality, whatever the performance indicator we're measuring, they're the ones that can directly impact and take action to change something. So making quality information as visible and actionable as possible, as opposed to a database, I think is really an aha moment for a lot of folks.
Yeah, really. We a very common term around our company is to have really short feedback loops, right? So that not only, it's not something you're just talking about as a group of managers or engineers, but those who are building or actually doing the step or the process or can see it and do something about it.
And then just to wrap up, especially since quality has such a big, important part of our supply chain, last couple of years, it's been unprecedented supply chain challenges, not only for us, but for just about everybody that wants to buy something or build something. What are you and your group particularly doing to make sure that we don't have quality lapses during this really tight supply chain that we're all experiencing?
Yeah, so this certainly has been a challenge for the entire organization, I think, too, as parts aren't available or have really long lead times. And it's, in order to continue to ship our product to the highest quality standards, sometimes we have to look at alternate parts or different electronic components or different things. And so I think what's really important as we do that is that we don't cut corners, and that we follow, again, I'll get back to the following the processes, right? Speaking back to as a hardware engineer who's impacted the most, and you and I have both been in that role, making those design decisions and having those peer reviews and executing the right tests, before we release that change, those are key. And I know our teams in this fight are certainly doing that, right? So that I think that's one of the most important things to maintain quality, that we're not cutting corners and that we're following the same processes.
Yeah. And you talk about processes, and certainly that's one thing that you've helped the entire organization make sure we have efficient and effective processes. But maybe I'll brag a little bit to you guys also put the science in quality too. You have what we refer to as a forensic lab.
Yeah.
All right. And where you can tear parts apart that may have failed to get to root cause of what did it. I kind of make it the equation to, there's so many of those crime shows, NCIS and stuff like that. This is equivalent to what you guys are doing over there, right? The science and the quality of really getting to root cause on what caused something to fail. Did you guys get your scanning electron microscope yet?
No, we're about to we're taking the final steps.
Oh, that's going to be so cool.
Yeah. Right now we're in the process of sending out some samples to make sure that, the different equipment we're looking at, we're going to get what we want from
Excellent.
it. So, our failure analysis lab, it's a lot. I like to think of it kind of like the morgue for electronic components, where they're performing autopsies. And so, if we ever do have a failure, whether it's, while we're making a product, say electronic component fails, or if something happens to fail later when it's in service, that comes down to this lab, and they perform that analysis, and with the mindset, what is the root cause? What caused this to fail? Yeah,
that's a really cool capability. Not only are we experts in building high reliability components, but we're also experts in understanding why they fail.
Yes. Yeah.
Well, that's great. Adrian, thanks so much for taking some time to talk about quality here at SEL. Appreciate it and look forward to having you back.
Yeah. Thank you for having me.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.